Hello guys, welcome back to another video. Today we will be talking about discriminant and nature of roots. So what is a discriminant? A discriminant is b squared minus 4ac. So if you guys have watched the quadratic formula lesson, you know that the quadratic formula is this. Alright. So basically, the discriminant is the thing inside the square root, right? And just for a little reminder, the a value is a coefficient or like anything that's before x squared. B is anything before x to the power 1, right? Like anything multiplied with x to the power 1 counts as a coefficient of it. And a constant is just a constant, a number, okay? Alright, so the nature of roots. Roots are essentially the solutions of an equation or a quadratic, right? And it makes the equation true. For example, if we have something like x squared minus 2x plus 3 equals 0, the roots are the solutions that are numbers that when you plug in as x, it outputs 0. It makes this whole thing true. Okay, so when our discriminant is bigger than 0, it means that there's two real distinct roots. When the discriminant is smaller than 0, that means there's no real roots. And when the discriminant is equal to 0, that means that there's one single root or a double root. It's the same thing, right? It's one single root. And a trick for when you're factoring is that if your discriminant is a perfect square, that means that the quadratic is factorable. Okay, this doesn't really apply to this lesson, but you might want to know about it for future purposes. Okay, let's do some examples. How many roots does this equation have? So you know that discriminant is equal to b squared minus 4ac. So b is going to be negative 3. So negative 3 squared is 9, minus 4, a is going to be 1, and c is going to be 6. 1 because there's an imaginary 1 in front of the x squared, because that's how you write. You don't write 1x squared. You just write x squared. Alright? So that's going to be your discriminant. This is going to be 9 minus 24, which is going to be 2, equal to negative 15? Yeah. So just double check that. Yeah. Sorry, my subtraction arithmetic is really bad. Okay. So therefore, that means that since discriminant is smaller than 0, that means that there's no real roots. That would be your answer. First question, okay? Okay. So now find the value of k for which 2x squared minus 3x plus k has exactly two distinct solutions. Okay, so we have to examine what two solutions means. So scrolling up, two solutions, two distinct real roots means that the discriminant is larger than 0. Okay, so discriminant, we first of all need to get the discriminant first before we set the inequality as larger than 0. So discriminant is going to be 9 minus 4 times 2 times k, which would be that. That is your expression for the discriminant. And since the discriminant is larger than 0, we can just plug this whole discriminant, we can set it bigger than 0, and then we can solve from there. So 9, you move k to the other side, k is 9 over 8. K is smaller than 9 over 8. So you can express this as k e round brackets smaller than 9 over 8. So from negative infinity to 9 over 8. Okay, so that's how you do that. And this is your final answer. Right? This is interval notation. Interval notation. You can leave it as this. This is okay. Like you can absolutely leave this as your final answer. However, some teachers would want you to do interval notation, which is not necessary and it's pretty useless. But yeah, you can either do this or this. They're both acceptable. They mean the same thing. Okay. So that's basically how you solve the first question. So now let's do a little bit harder question. The equation y equals x squared plus 3px plus 14p minus 3, where p's integer has 2 equal roots. Okay, so 2 equal roots. What does that mean? 2 equal roots means a double root, which means discriminant is equal to 0. Okay, that's the first thing you have to establish. And then we know that these are not really numbers, right? These are really, they're expressions. But you can see that this is clearly a, the e value. 3px, that's the whole thing, right? This whole thing is b, and this whole thing is c. How do you know it's b? Because these two are before the x to the power 1. They're multiplied with the x to the power 1. Therefore, it's a b, right? B value. So now let's calculate the discriminant. Okay, so b squared, so 3p squared minus 4ac. Okay, 9p squared minus 4, 14p minus 3, p squared, minus 56p plus 12. Okay. So you have to discriminate there. Quick reminder, if you guys have not learned the lesson of how to solve quadratic inequalities, please go through our playlist and YouTube channel to watch that video. Anyways, here, so number 2, second step is that to simply set it equal to 0. For this one, you don't have to solve a quadratic inequality, but it may show up, right, in your practice or something like that. Okay, so make sure you watch that quadratic inequality lesson. For this particular question, you don't have to know that. Okay, so what two numbers multiplied equals to 108, and what numbers add to negative 56? Okay, you can either just jump straight to the quadratic formula, but you know, factoring is usually cleaner. In this case, I'm not sure if it is. Just try a few more factors. Okay, so you have negative 54 and negative 2 are my two factors. Okay. Negative 54, negative 2, right? Yep, that makes sense. Okay, you're just gonna factor it like normal. Zero. Factoring, you can really do many ways. There's many ways to factor. I just do my my way. Just basically just take the first term, right, without the square, remove the square, and then you minus whatever the factor is, right, like that, and then you just divide by the common you know, multiple there is. Okay, so now that means that p can either be 6, oh, it's an integer, right? So p is 6 because p cannot equal to 2 over 9, simply because it's not an integer, right? 2 over 9 is not an integer. It asks for an integer, right? But p equals 2 over 9 is not. For this value of p, solve the equation x squared plus 3px plus 14p minus 3. Basically, it's saying that you plug in p equals 6 into p here, this equation here, and you solve for x. Okay. Alright. So you have x squared plus 3 times 6 times x plus 14, 6 minus 3 equals 0. Okay. Expand all of your brackets and simplify terms until you get a quadratic like this. Let me just check if you can factor this real quick. Oh, okay. Okay, right. This has, so this, the discriminant of this is going to be 18 squared minus 4 times 1 times 81, which equals to 0. So going back to our thing here, if it's equal to 0, it means it has 1 single root, which gives us a hint there that means that this equation is going to be a perfect square trinomial. Alright, so we can just factor out straight away to this 0, which means x equal to negative 9. Right, because it's a perfect square trinomial. When there's only one solution, that means that it's a perfect square trinomial. Always, always, always remember that. If you plug in a quadratic, right? If you plug it in to the discriminant formula and you get 0, that means that you jump straight away to factoring it as a perfect square trinomial. It's much easier, right? Or you could have just found the factors and factored normally, right? But I chose to go this way because it's much more simple. Okay. Now, the equation 2x squared equals 4kx minus 13kx squared plus 2, where k is a constant has no real roots. Show that k satisfies the inequality. Okay. No real roots. Immediate buzzword. Discriminant is smaller than 0. Alright. Now you come in. Now the quadratic inequality lesson comes into play. Alright. But first, let's just get the discriminant straight. Let's just first of all, let's rearrange this thing into a quadratic first, because before you plug into discriminant, you always have to get it into this form. Equals 0. Okay, always make it equal 0. So let's just rearrange it and see what happens. Actually, I'm gonna move it to the other side because it's easier. That. Okay. There you go. Again, as I said earlier, this is going to be your A. No, this whole thing is going to be your A. Actually, before that, let me just factor out. When you look at this, right? You see 4 terms. You see, oh, what the hell's happening? But let me, show this. For these 2 terms specifically, because an A value, A term, let me scroll up again. A term is always before an x squared. So what can you do? So these 2 terms have the common x squared. So factor out x squared, right? Boom. Factor out x squared. There you go. Is that easier to look at, right? Now you have separated your A term, right? From this messy thing, you've factored out x squared and you've got your A term. For kx minus 2 equals 0. Boom. Kx for negative 4k is obviously your b value. Okay. So discriminant is going to be 16k squared b squared minus 4ac. There you go. Discriminant is going to be 6 expand your brackets. Okay, now you've got this. It says, show that k satisfies the inequality, that inequality. Okay, so that hints us. So this, we had to make this into this. What we can do is just divide this whole thing by 8, because you want a 16 before the k squared. You want 2 in front of the k squared. Now you have 16. So only way you get 2 is to divide everything by 8. So let's hope that we've got it right and everything just simplifies nicely. 104 divided by 8 is going to be 13k. 160 divided by 8 is 20. There you go. I just basically moved this in front of the 160 you should be doing that, you know. Okay, boom, you've completed part A, full marks. Now part B. Hence, find the set of values for k. Okay, so we've got our discriminant here, right? Discriminant. We know that since there's no real roots, discriminant has to be smaller than 0. So let's do it. So 2k squared plus 13k plus 20 is smaller than 0. Now, again, quadratic inequalities come back. But before this, we need to solve this equation first. Get the roots of this equation first. So what multiplies together equals to positive 40? What adds to 13? Let me see. 8 and 5. Right? No, 8 and 8 and 5. Yeah, 8 and 5. All right. a little bit of like forgetfulness there. Okay, 8 and 5. So again, start factoring. You get k plus 4, 2k plus 5 is smaller than 0. Okay, you draw your graph. Negative 4 is on here, and negative 5 over 2. Wait. Negative 5 over 2 is on here, negative 4 is on here. Quadratic opens up like this, right? Now it's where is the quadratic going to be smaller than 0? It's going to be in between here. It's going to shade it in between these two, in between the two roots, right? Because that's the only place where the quadratic is below 0. Okay, so what we can say is that since it's between the roots, right, between these two roots, the shaded area, we can say that k is an element of square brackets from negative 4 to negative 5 over 2. This is going to be your answer. Or you can say k is between, you can say like that. This also works, okay? This or this. Both are accepted. See? So yeah, this one's a pretty hard question, especially when it comes to the quadratic inequality part, but overall, it's manageable. Okay, so I hope you guys enjoyed this lesson, and please leave any comments or any concerns below, and hop on our Discord server, alright? Or leave a thread. Thank you.